Good day, everyone. For today's presentation, our group will be discussing gypsum board suspended ceilings. The primary objective of this video is to explain how gypsum ceilings are constructed, which includes the processes, safety considerations, and standards for quality control measures relevant to its construction. Now first, we need to define what false ceilings are in order to fully understand gypsum ceilings. False ceilings are artificial ceiling systems applied to conceal ductwork and wirings to provide a cleaner finish look. They are subordinate to the main ceiling, which can be the roof system or the reinforced concrete slabs. There are various types of false ceilings, however, here are some of the most commonly used: gypsum ceiling, plaster of Paris false ceiling, and wooden false ceiling. Among these, the focus of our discussion is the gypsum ceiling. According to Gyprock Malaysia, gypsum ceilings are basically plaster boards or drywall which are manufactured and uses ready-to-install calcium sulfate boards for false ceilings. They are typically supported by the above concrete slab or the roofing system.
Elements of a gypsum board ceiling. Beams of inverted T shape, also known as T-beams or simply Ts, are used to form grids to support the gypsum boards. Main Ts are long and perpendicular to the shorter dimension of the ceiling. Cross Ts are shorter and pass through designated slot in the main T's web. Cross-section of a T-beam is shown here. There can be slight variations depending on manufacturer. Gypsum boards fit into the channel between the flanges and the widened head of the web. Perimeter angles are L-shaped beams that form the border of the grid system. This can be attached to the fixed end, wall, or contact surface using screws or rivets depending on the construction plan. Lay-in tiles or the gypsum boards are placed on the grid. They can be fixed with screw or clips. Finishing with paints or fillers are applied depending on design. Hanger wires connect the grid system to the primary ceiling, which is the roof part or the reinforced concrete slabs.
The materials in installing gypsum board suspended ceilings vary depending on the variation of method used, but presented here are the most commonly used. First and foremost, the insulation cannot push through without the gypsum boards. For the framing system, we would need wall studs, deflection head tracks, Ts, GIL angles, and main channels. For the connection system, flat straps, backing and wire rods, anchors, screws, and web cleats would be needed. Lastly, for finishing, we would need jointing tape, jointing compound, furring channel, and fire and acoustic sealant.
Like in any project, the first step in installing a suspended ceiling is planning. So before anything else, preliminary measurements should be conducted, including the exact dimensions of the room where the ceiling will be installed. At this stage, we also have to consider where the mechanical, electrical, and plumbing systems will be located. Next, we have to decide on a ceiling pattern. We can choose from either a 2 feet by 2 feet pattern, which is shown in the middle figure, or a 2 feet by 4 feet pattern, which is the one on the right. This will depend on the desired ceiling look or just simply on which choice is more economical. To illustrate the planning process, let's look at a room of dimensions 20 meters by 20 meters. So assuming that a basic flat ceiling will be installed, this will be our grid layout. First, the perimeter or wall angles, as the name implies, are installed along the perimeter of the ceiling. Next, we have to locate the main T's. Regardless of which pattern you select, starting from the center line, draw the main T's 4 feet or 1.2 meters apart. Make sure that the space nearest to the walls is greater than 12 inches so that the panels at the ends of the room will not be too narrow. If the space is less than 12 inches, try moving the center line by 1 foot in either direction and find the best layout. Next, add the 4-foot cross tees using the same procedure done with the main tees. Once the center line is established, place the main tees at 2 feet or 0.6 meter intervals. Position the tees so that the space nearest to the wall is equal on both sides and as large as possible. For a 2x4 ceiling pattern, this will be the final grid layout. However, if a 2x2 ceiling is preferred, we just have to add 2-foot cross tees between the main tees as shown by the green lines in the figure. Now that we're done with the grid layout, the next step is to install the perimeter or wall angles. First, choose an appropriate ceiling height. Be sure to maintain a 4-inch minimum clearance below the lowest air duct, pipe, or other obstruction. Then, mark a perimeter chalk line 3/4 inch above the desired ceiling height. Make sure to check the chalk line with the level. Next, align and attach the top of the perimeter angles with the chalk line. Place screws every 2 feet or closer. When adjoining angles on longer walls, be sure to butt factory ends together. For inside corners, cut the angles straight and overlap them as illustrated in the top figure. For outside corners, refer to the figure below. Miter the perimeter angles at a 45-degree angle and fit them snugly together.
The next major step is the location and hanging of the supporting suspension wires or L-shaped angles. Before we map out and install the supporting elements, we need to ensure first that other fixtures such as lighting fixtures, among others, are already established. This is for practicality purposes, as constructing other fixtures, wires, or ducts will be more difficult and problematic once the grid system is already established. Once all the other fixtures are placed, we can now locate the supporting elements of the ceiling. First, we locate the main tees in the room since they will be supported by the wires or angles. We can do this by stretching a tight line from the top edge of the perimeter angle on all sides of the room at each position which the main tees are to be placed. It should be noted that the main tees should be perpendicular to the room joists. Next, we need now to reduce the wires or the angles to their specified length. Note that the length of these supports should be 12 inches longer for wires and 100 millimeters longer for the angles than the suspension distance. Since we now have the location of the main tees from the previous step, we can now locate the suspension hanger for each main tee as specified in the plan. Once we locate the placement of each hanger, we can now place the support, making sure that it is well fastened. Since there are two possible materials that can be used as support, we have to differentiate the fastening procedure for each. For suspension wires, we need to apply screw eyes, screw hooks, fixing bracket, or drill the fastener with the appropriate screw directly to secure the wires accordingly. For suspension angles, we need to snip the flange at a specified length and bend it to form an L shape. Then we secure the steel to the soffit of the slab with a drill point M4.2 wafer head screw. To insert accordingly the screws, we drill the upper slab at specified centers along the line of the main channel offset by 50 millimeters. Finally, we hammer the wedge anchor to fix the angle hangers to the soffit slab, as seen in the two pictures that are boxed below. The last sub-step for this part is to attach the hangers every 4 feet, or as specified in the construction plans, along the assigned suspension. Ensure that the string and the angles have no bends or kinks.
The next step is to install the main tees. First, we should note that most main tees are 12 feet long and have cross tee slots every 12 inches, starting at 6 inches from each end. The picture on the left shows the parts of a main tee, and the picture on the right shows a main tee with a cross tee attached to it. Using the layout sheet made earlier, we first determine the distance from the wall to the first cross tee. As you can see on the layout on the left, this distance is 0.4 meters. Then we measure this distance along the top flange of the main T and locate the first slot beyond this point, as shown on the picture on the right. From the slot we located earlier, we measure back the distance, which is 0.4 meters or 400 millimeters. We then subtract 1/8 of an inch to take into account the thickness of the wall angle. Saw the main T at this point. If the room where the suspended ceiling is to be installed is less than 12 feet in length, cut the main T's to the exact measurement of the room, again subtracting 1/8 of an inch from the other end to account for the thickness of the wall angle. If the length of the room is longer than 12 feet, we will splice the main T's. Take care to align the splice such that the suspension wires previously installed are correctly positioned. The diagram on the left is an example of how to splice correctly, while the video on the right shows how the main T's connect. Finally, we installed the main T's using the hangers we placed earlier. Make sure to use a long level to ensure that the main T's are aligned with the wall angles.
Following the installation of the main T's is the placement of the cross and border T's. Similar to the previous steps, we need to locate first the position of the cross T's by the pattern specified in the construction plans. In the sample plan we have, they are yellow and green lines, spaced 4 feet and 2 feet respectively. To install the cross T's, we need to insert them into the slots of the main T's and lock their ends. As shown in the video, we need to push the cross T into the slot and make sure that the lock tab on the cross T passes through the slot of the main T. Finally, we install the border cross T's between the perimeter angles and the last main T nearest the wall. We need to allow 1/8 inch spacing from the angle and the last T. The border T should be cut, as illustrated in the video, and installed by inserting the connector in the main T, as did in the regular cross T from the previous step, and resting the cut edge on the wall angle.
Installing of the ceiling panels. The gypsum board panels are fixed with retainer clips when the panels are placed above the flanges of T-beams. There is no designed screw hole or no drilling preferred. Clips support the panels from above. The figure shows the view of panels without rivets or screws. The flanges of T-beams are exposed. When rivets or screws are applied, longer dimension of the board is perpendicular to the main T's. Screwing must be 3/8 of an inch away from the edges of the board. The boards may be fixed below the flanges of T-beams.
After installation, we go to the final step, which is finishing. Finishing is the improvement of the gypsum board's appearance after work. So there are 5 finishing levels, each of increasing quality. At level 0, there is no finishing done, while at level 5, there is a smooth and clean finish. Finishing levels involve the same steps, but more coating is required for higher levels. The process is as follows. First, a joint compound mixture is applied to fill small gaps between gypsum boards. Secondly, a special embedment tape, usually 4 inches wide, is overlaid in the same gaps. Next, a coating that is wider than the tape is applied. The same coating is applied on its edges, alternating until the desired consistency is achieved. Finally, especially at higher finishing levels, a thorough sanding is required to remove rough marks or solids to ensure a smooth surface for painting, or if desired, multiple ready-made texture mixtures as shown can also be applied.
For general safety considerations, all health, safety, and environment rules and regulations shall be adhered to strictly to ensure the safety of everyone. All tools and materials shall be inspected before installation to make sure the tools are perfectly functional and the materials are up to standard and free of defects and damage. Appropriate and correctly fitted protective equipment shall be worn. This includes a safety helmet, shoes, belt, vest, goggles to avoid eye irritation, and gloves to minimize skin contact with materials. Since electricity is a major hazard, turn off the electrical lines before installation. Additionally, adequate lighting and ventilation shall be ensured as lighting is generally poor in ceiling spaces. Next, avoid stepping on ceiling joists and use ladders instead to avoid risks of falling or other injuries. Lastly, the work area should be clear of debris and use tools and other unnecessary objects to avoid stepping on them and tripping. The gypsum boards must be stored in rooms with good condition. They must be protected from rain, sunlight, and wind to prevent weather damage, which can not only affect the quality of the boards but also cause serious health consequences due to mold and fungus growth. The boards must also be handled well. On the working level, they must be stacked in a designated area. The safest way to store gypsum panel products is to stack them flat on risers that are placed on a solid surface. They shall not be stored on a single pile, but rather distributed and spread out evenly to distribute the load. In some cases, however, where floors are not able to accommodate a concentrated point load of gypsum panels, the safer procedure is to distribute the board in vertical stacks around the sides of the room.
Quality control is a system that is developed to ensure that products and services meet or exceed customer expectations. These systems are usually developed by multiple disciplines to ensure that the products are both of high quality and are marketable. In engineering, quality control is implemented to ensure that structures are properly designed, installed, and maintained such that the structures remain safe and are able to serve their purpose. For gypsum board suspended ceilings, the common causes of collapse include the improper installation of the suspended ceiling, shown by the picture on the top left of the failure of the panel support, the improper addition of fixtures or equipment, shown by the picture on the bottom left of a collapsed suspended ceiling due to the additional load of a cabinet. The inadequate maintenance and inspection of the ceiling is shown by the picture on the bottom center of a collapsed suspended ceiling due to water ingress and rusty screws. And finally, the inappropriate alteration or removal of structural elements is shown by the picture on the bottom right of a failed timber supporting frame. Quality control for the design, specification, installation, and testing of the suspended ceiling can be practiced by conforming to established standards. These standards include the British or European standard for the requirements and test methods for suspended ceilings, and the Australian or New Zealand standard for the design and installation of suspended ceilings. Since the British standard for suspended ceilings focuses more on requirements and test methods, its provisions include testing the suspended ceiling with a uniform load of 0.25 kilonewtons per square meter and a concentrated load of 0.9 kilonewtons. It establishes that the factor of safety for suspended ceilings must be at least 2.5, and that suspended ceilings should not be used to support additional loads from partitions unless they are specifically designed to do so. On the other hand, the Australian standard focuses more on the design and installation of suspended ceilings. Some of its provisions include designing the ceiling such that it is structurally safe for at least 15 years, making the supporting structures out of durable and corrosion-resistant materials, and designing the ceiling such that the failure or removal of one hanger or support should not cause the progressive collapse of the whole ceiling. Based on these standards, the Building and Construction Authority of Singapore created a suspended ceiling installation checklist to ensure the proper installation of suspended ceilings. A part of it is shown here. They also provide a checklist for the inspection and maintenance of suspended ceilings, which you can also see here. That's all for our presentation. Shown here on the slides are all the references we used. Thank you for watching, and we hope that you learned a thing or two about the design and installation of gypsum suspended ceilings.